In this video, we're going to use source transformation in order to find I naught. But before we do that, let's take a look if you want to do something like mesh current. We've got 1, 2, 3, 4, 5 meshes here. That'd be a pretty big pain. Node voltage wouldn't be too bad. We've got the node on the bottom, looks like maybe 3 nodes here, but 2 of them you might deal with supernode depending on where you chose your ground. However, what we're going to do now is we're going to use source transformation, and we won't ever really solve a system equations at all. We're just going to simplify the circuit. So the first thing I will do is I see the 6 ohm and 3 ohm are connected both on top and bottom, so those are in parallel. And so 6 in parallel with 3 is going to be 2 ohms. I can also combine this 1 ohm and 4 ohm here. So I'm going to have 2 ohm resistor in parallel, with a 5 amp current source. Then we've got our voltage source over here. We've got our resistor. Got our current source. And then 5 ohm resistor. Now, what I'm going to do is I'm going to use source transformation on the left here. I have a resistor in parallel with a current source. I can replace that with a voltage source in series with the same resistor. And whichever way the arrow is pointing, in this case is up, that's where the positive is going to be on the voltage source. And we use V equals IR to find the value there, so 5 times 2 is going to be 10 volts. Then we go ahead and continue on with our circuit that we had there. And then at this point, what I'm going to go ahead and do once I finish drawing this is realize that, yes, they're not directly next to each other, but all these 3 elements are in series, so it doesn't really matter which order they're in. So I can go ahead and combine the 10 volt and the 5 volt to make a 15 volt source here. And then continuing on, redrawing the last part of the circuit. Then I will perform another source transformation. Voltage source in series resistor becomes a current source in parallel with the same resistor. And we do V equals IR, so I is V over R, so it's going to be 7.5 amps. Continue drawing our circuit here. And once we get to this point, everything is in parallel with each other. It was really just that middle 5 volt source that was messing up the parallelness, but now everything is in parallel. And so I can combine the 2 current sources together. 7.5 going up and 3 going up is 10.5 going up. I'm going to go ahead and combine not all the resistors, but the 2 ohm and the 5 ohm. I'm particularly not combining the 7 ohm here because that has the I naught I'm looking for. So let's see, 2 parallel 5 is 2 times 5 over 2 plus 5. That's going to be 10 over 7 here. So we've got a 10 over 7 resistor there, and then we have the 7 ohm. And if I want to find I naught, I can go ahead and use current divider here, the total current times the resistance we're not at over the sum of the 2 resistors. If I want to simplify this a little bit here, I'll go ahead and over top and bottom by 7. This is 10.5 times 10 over 10 plus 49. It's going to be 59. So I'm going to have 105 over 59 amps. And that's my. Now notice this did take a while here. There was several steps involved that I showed. And maybe it would have been faster to use, say, node voltage in this problem. But I will say doing it this way, you get to skip the linear algebra solving system of equations. And if you get good at this practice of switching back and forth, it can go very fast. In fact, honestly, when you get good at this, you could just skip some of these steps, maybe add things in your head and so on. And if you have less writing there, you can do this method very, very fast. So again, maybe source transformation is not always the best method just to solve a circuit, but it's definitely something you want to keep in your toolbox for when it works out well.